All right, in this video, we're going to start chapter 7, which is thermochemistry. Oops, lowercase c. There we go, thermochemistry. Really, that's just another way of saying the energy of chemical reactions. So that's what we're going to be talking about now. But first, in this video, we're just going to talk about energy in general and just lay some groundwork. So let's just define what energy is, because we all kind of know what it is, but maybe we can't put it into words. Simply put, it's the ability to do work. I mean, we can use that term when we're just talking in everyday language, or, I don't have any energy, I'm not going to be able to go do any work. Or in terms of science, physics, chemistry, what we mean by the ability to do work is have a force acting over a distance. And we'll talk more about both of these things as we go. But work is just force acting over a distance. So if you push a semi, for instance, and it has its brakes on, or it's just really heavy and it doesn't go anywhere, and you push it for an hour and it doesn't move, there's no distance change, then you have done zero work. However, if you push a pen a centimeter across the table, now you've done work, okay? And that's just in terms of the physics and the definitions. So let's talk about two types of energy, or as I sometimes like to say, the two flavors of energy, okay? We can divide all energy into these two types, and I'm sure you're vaguely familiar with these at least. They are kinetic energy, and kinetic energy is energy of motion. And if you've taken physics, you've probably seen this equation, E, K, and sometimes it's abbreviated KE. It doesn't really matter, but it's 1/2 mv squared. Okay, 1/2 mv squared is the equation. We're not going to be using that really, but there it is. Okay, when we talk about kinetic energy, and here we're mostly going to be dealing with thermal energy. That's let's just write that down. Thermal energy. That's just really molecular motion. That says molecular, trust me. Okay, molecular motion, just molecules moving around, that's what thermal energy is. Again, we'll talk more about that as well. So, let's talk about the other type of energy. There's kinetic energy, and the other type is potential energy. I don't have an equation for you here, but this is just simply energy that is stored by position, or condition. What does that mean? Well, let's talk about those two separately. First off, let's talk about energy stored by position, okay? Let's talk about that. So energy stored by position, if you were in Chico, I don't know if you are or not right now, and you drive up the Feather River Canyon, you'll see a series of dams. And those dams aren't really used for drinking water. I mean, the lowest ones are. But they are used for hydroelectric power, okay? So that's energy stored by position. The water is high up in the mountains, and we let it fall through a turbine, and we can get energy out of it. So that would be one example, a dam. Another example would be maybe if we were all in elementary school and we took a rubber band and snapped somebody with it. So a rubber band, if you pull a rubber band back, that can have energy stored by position, as can a spring. Lots of things can. Okay. Not surprisingly, we're not going to talk too much about that. Whoa, wrong button. We will, however, be talking about energy stored by condition because these are chemical energy types of things. So these are like food. You guys all hopefully had something good to eat today. And one of the reasons you eat is for energy in the form of glucose, sugar, fat, or even protein. They will all give you chemical energy. Okay. Fuel, if you drove anywhere, which I am driving a heck of a lot less these days, fuel is energy stored by chemical composition. We all know that most fuels are highly, highly flammable. And of course, we all carry around one of these in our pockets nowadays, a battery. And your cell phone runs on a battery, and that's just a chemical reaction. And the interesting thing about a battery, which you'll learn more about in Chem 112 if you take it, but when you're using your battery, there's a chemical reaction occurring. It's releasing energy, high energy electrons, and we use those to power our phones and other things like the computer I'm using right now. When that chemical reaction starts to run out, we can plug it in and reverse that chemical reaction, store in some more electrons, high energy electrons, and then use them later. Okay, pretty handy. So let's talk about units of energy. We always got to worry about our units. So the units for energy come from that equation 1/2 mv squared. Okay, this guy right here. So I'm just going to write it down. I'm not going to really go through the derivation, but 1 kilogram, that's mass, and meters squared will give you m squared over v squared. So 1 kilogram times meters squared per second squared is equal to 1 joule. That's just a definition. And joule is a derived unit, okay? Which means it's made up of other base units. Whoops, I wrote v squared down there. That's supposed to be second squared, sorry. I'm glad somebody caught that. All right, and then one other unit that will come up later. It's kind of a weird unit, so I like to mention it. It's a liter atmosphere. Liters times atmospheres. And that is equal to 101 joules. We'll talk about that when we talk about work, pressure times volume work. Okay? So you just want that in your notes for later. Well, but the joule is the SI unit for energy. Okay. A couple other energy units that we will talk about here is the calorie. And we don't use these too much anymore, but it's the energy required to raise 1 gram of water 1 degree Celsius. Okay? And we want to be able to put that into units of joules, so 1 calorie is equal to 4.184 joules. And that is an exact measure. If you remember, that means it has infinite units. Okay, I'm sorry, infinite sig figs. And then a couple more just for fun. Calorie with a big C. I'm going to exaggerate it just so it looks like a big C. Calorie with a big C. That is 1 kcal, which is just simply 1,000 calories. Or another way to put it would be a food calorie. If you look at a package of food, when it lists the calories, it lists it with a capital C. And for whatever reason, that's just the unit that we use. If you go to like the Asian food market and get a bag of chips or some candy, look at the back, they actually sometimes have joules or kilojoules on the back of them, and sometimes it'll say kilocalories, but those are all units of energy. All right, 2 more just for fun, and then a couple of definitions. How about a BTU? You guys maybe have heard this, BTU. That's a British thermal unit, and that's, now let's write it out. British thermal unit. That is the energy required to raise 1 pound of water. 1 pound of water, 1 degree Fahrenheit. So that's why we don't use it. It's pounds in Fahrenheit. So that's definitely a not SI. And then here's an interesting one. You might think that the power company charges you for power. They don't charge you for power. They charge you for energy. And they charge you by the kilowatt hour. So 1 kilowatt hour. This gets into the definition of watts and joules, but we're not going to go there. I'm just going to tell you, when you look at your power bill or your parents' power bill, whatever, it lists kWh, and that's a kilowatt hour. 1 kilowatt hour is equal to 3.60 times 10 to the 6th joules, so about 3.5 million joules is what you're being charged for. And that's, depending on where you live, anywhere from 15 cents a kilowatt hour, up to 25, 30 cents a kilowatt hour. Okay, 2 definitions and then we're done. Temperature. I'm sure you can all tell me what the temperature is, but can you tell me what temperature is? So this is just the average kinetic energy of the molecules or atoms of a substance. So another way to put that is that temperature is just a measure of how fast particles are going. Okay? High temperature, particles are going fast. Low temperature, particles are going slow. And that's all temperature is. It's just a measure of the average speed. And kinetic energy, remember, is related to velocity. That's why I say temperature and speed are the same thing. Okay? And then heat. We all use the word heat, but do we know what it is in a science setting? This is really just the amount of thermal energy transferred. Okay, and it's always hot to cold. Okay, there we go, trying to make a short video and it runs long. All right, that's enough for now.